Hello, everyone. As we all know, a real computer doesn't have a mouse. What a real computer looks like is just like this. It gives you a text interface, and then you type things into it, and this is the correct way to use a computer. But if a computer does have a mouse, then you might want to know how to use the mouse, and that's the point of this video. So this mouse is basically this video is basically about how to do stuff with a mouse in DOS, because I admit that there are some games and other programs that have made good use of a mouse at various points in history, and so there may be some situations where it could be advantageous to have a mouse. So what I wanted to do in this video is show off basically three programs that show how to do basic things with a mouse in DOS. How to set up a mouse cursor and move the mouse cursor around and read the position of it and allow you to click on things. So I have three programs. Hopefully I'll be able to get all three of them into the video. And I'm doing this in DOSBox. When I first made this video, I tried doing it in FreeDOS. And I was about halfway through the video when I found out that FreeDOS doesn't let you do direct memory writes. I could not find a way to do a direct memory write in FreeDOS. So for that reason, I'm back here to DOSBox, because DOSBox allows you to do what I need to do. So let's go ahead and get started. What I'm doing here, I'm going to be using the assembler called A86, just because this is what I've been using for more than 20 years to assemble all of my assembly language programs, and it's what I'm used to. Some people prefer NASM or MASM, and those might be more popular, but I just tend to use this partly because it's what I know, and partly because I'm a hipster, and so I enjoy using things that people have not heard of before. Although you may have heard of this, but anyway. So let's see. Let's get started. What's the first program that I want to do? The first program that I want to do is, just creating a mouse cursor, like how to do a graphical mouse cursor on the screen. So before I get started, actually, I wanted to show help PC as a reference, but I just realized that I don't have help PC on this instance of DOSBox, so actually it's not an option. Okay, you know what? I'll just go ahead and start writing the program, and we'll see how it looks. So let's call it mousecurse.asm. Here we go. Now, DOSBox does not come with an edit program, but I've copied the edit program from FreeDOS. It looks kind of like the MS-DOS edit program, except it's not. Obviously, it has some functionalities which are different, but it's basically, it works kind of like, it says the clone of MS-DOS editor, but actually it works differently from MS-DOS editor in some ways. But yeah, let's not worry about that now. So what do we do? The basic interrupt. We're going to use just a simple interrupt routine, but the basic interrupt routine for stuff to do with the mouse is interrupt 33 hexadecimal. If you're using A86 as I am, numbers like this, which are just entered in without any qualification, are usually assumed to be decimal numbers. So because the interrupt that we want to use is 33 hexadecimal, you have to put an H at the end. I think you can also do 0x33. I think that will also make A86 interpret this as a hex number, but I just put H at the end, and then it's in 33 hexadecimal. So this is the mouse interrupt. This is where you get mouse services from the Microsoft mouse driver. I guess I can mention in passing, there were other mouse drivers for DOS back in the day, which had different functionality or additional functionality to the Microsoft mouse driver, but none of them were ever very widely used. In the times of DOS, virtually everything, like every single program, just used the Microsoft mouse driver. There really was nothing else. There was no other game in town. So so I'm not going to be doing any other types of mouse interfaces, because there weren't any that were widespread at all in DOS. So yeah, so for the Microsoft mouse driver implementation, the interrupt call to use is in 33H, and the function to set your mouse cursor is, I believe, 9. Is that right? Yes. So let's actually, let's do AX. So let's move 9 into AX. And there you go. This is the function to set your mouse cursor. But we need to do a few other things. We need to add a few things before this will work. So I'll annotate this as I go. So set mouse cursor in graphics mode. We need to set BX because this will be the horizontal hotspot of the mouse cursor. So a mouse cursor is usually more than just one pixel, but whenever you click with the mouse cursor, there's one pixel that's the so-called hotspot, which means that defines where the cursor is actually clicking, or what part of the screen you're actually clicking on. Obviously, most of you will be familiar with the mouse cursor that looks like an arrow, and obviously in the case of the arrow, the hotspot is the tip of the arrow. Similarly, you've probably seen a mouse cursor which looks like a hand with a pointing finger, and again, usually the pointing tip of the finger is the hotspot in that cursor. So you'll need to specify a number here that sets the hotspot, and this is the horizontal one. And then there's also a hold on. There is also a in CX. This will be the vertical hotspot. So, for the vertical hotspot, I'm just going to specify the top. So I'll say 0, which means the topmost row of pixels. And then for the horizontal hotspot, we can fool around with this, but in my testing, I think A was a good spot. 0 is the same in any number system, whether it's binary, decimal, or hexadecimal, so you don't need to put any qualifier for the 0. For this, I put H on the end to indicate, actually, the H is redundant since you can't, obviously there's no such thing as A decimal because A is not a digit in decimal. But if you just do this, A86 will complain that it doesn't understand what you mean here. So if your hexadecimal number begins with a letter, you have to put a 0, prefix it with a 0 so that it interprets that as a hex number. So that's fine. So those set the hotspots, and then what we need to do, ES DX needs to be a pointer to the 16 by 16 bit cursor bitmap. So what I'll go ahead and do is I created ahead of time, I created a file here called mousecurse.txt, and it looks like this. So this is what our cursor will look like. So let's go ahead and copy this. I'll just say, copy, Control C, and then we can go back to mousecurse.asm, our assembly file, and I'll put the text down here. Oh, does Control C and Control V not work here? It's supposed to. But it pastes an O instead of what I wanted. Hold on, what's going on here? Let's try this again. Copy. Okay, it looks like it copied. Paste. It pastes an O. Oh, you know what? Is it just... No, actually, I have no idea where it's getting an O from because there's not even a letter O in this text. So where is it getting an O from? If I have to... Oh, you know what? I bet it doesn't work across files. That is extremely irritating. That probably means that... Wow, that is really just, that's like extremely annoying. That means that I will not be able to copy and paste that into this file. Okay, well, there's a way around that by doing it outside of DOSBox. Gosh, that's really stupid. That's really stupid of the editor that it doesn't let you copy and paste text between files. I'm going to assume that that's the reason why it didn't work, unless there's something that it did wrong, but I'm going to assume that's probably what happened there. Gosh, that's so dumb. Why do people write software like this? I swear. I mean, the most basic functionality, like literally the simplest things, become so hard to do because people. Okay, so let's. I did it in my operating system. So let's see if I open up mousecurse.asm now. Yeah, okay, so it's there. That's fine. Okay, so what we'll need to do here is. In A86, you can just say move ES seg cursor bitmap. And then similarly for the offset, you can just say move DX offset cursor bitmap. There we go. So this will, at assembly time, this will actually take the numerical values of the segment and offset of cursor bitmap of this point in memory, and plug them into ES and plug them into the program here so that they get loaded into ES and DX. So that's one nice thing about using an assembler program instead of typing everything into DOS debug, which would require you to manually figure out the offset of this stuff here. So what is this stuff, and why are there these two blocks here? Well, I'll try to explain. So the second part here, this is the actual cursor. This is the cursor mask, and this shows you what the cursor itself will look like. So everything that's a 0 indicates a black spot, and everything that's a 1 indicates a white spot. So this function gives you monochrome cursors. You can't do color with this. So it's very simple. It's just a monochrome bitmap where 0s are black pixels and 1s are white pixels. Because the endianness here is reversed from what you would intuitively expect, these are backwards. So the part that you see here on the right side will actually be on the left side of the cursor, and this part here on the left side will actually be on the right-hand side of the cursor. So if you imagine these swapped, you could actually, in the text editor, I could actually swap them around so you could see. But basically, this part here is going to be the finger. Like you can see all these ones form a kind of a pointing fingertip here, and then down here this is the body of the hand, and then down here you have the wrist and the arm coming out there. So, and then this here is the right hand side of that hand. So this is what the actual cursor will look like. This is the so-called screen mask. What this means, this doesn't specify what the cursor looks like. It specifies what parts of the cursor are see-through. So if any bit that's a 0 is opaque, it covers up what's underneath it. And then whatever is a 1 lets the background underneath show through. So it kind of creates a cool see-through effect if you have parts of the cursor that are turned on, that are white but are see-through. I'll show that a little bit later, but right now let's go ahead and get this program finished so we can see the cursor. So this should be all that we need to do for interrupt 33.9. So this block here as it is should be done now. What I do need to do, what I shouldn't forget, is to set the video mode, because by default DOS runs in a text video mode. So we need to set our video mode. That should be then move AH0. This tells interrupt 10 to set the video mode. AL13H, again, this is mode 13 hexadecimal VGA. And it is a hexadecimal number, so make sure that you indicate that it's a hexadecimal number, because if you just do this, then A86 will interpret this as a decimal number, and you will get some other video mode. So make sure to do that, and then of course for the interrupt as well, do not 21, 10. Interrupt 10 is the video interrupt. So this should set us to mode 13 VGA. So I think that's most of it. There are just two things that we need to remember. First of all of this code here sets the mouse cursor, but it doesn't turn it on. After doing this, you'll need to turn on the mouse cursor to see it. So the function for that is just int 33.1. So you just set AX to 1 and then call interrupt 33 and you're done. Then what you also shouldn't forget is to end your programs properly, because if you don't do this, then your program will probably crash, because right after doing this, it will start running this as code, when this is obviously not meant, it is not instruction code, but it will run that as instruction code and probably do something very unexpected. So, yeah, so the standard lines to end an assembly language program call DOS interrupt 21 for C. Okay, we should be set here. I think that should be all we need. So I'm going to go ahead and say A86 mouse curse.asm. Okay, we have no error messages. That's a good sign. That's promising. Let's go ahead and run mousecurse.com. And there we go. It works fine. So here we have a mouse cursor that I can use to point at stuff. And you won't see it very clearly if the text is white like that. But does it really give me white text? Okay, that's a bit, wonder how that'll look. Let's try, just as an experiment, let's try changing the screen mask here. I'll make the finger all ones. So this will not change the appearance of the cursor itself when it's on a black background, but it will change how it behaves or how things look when it's over something else. So let's try this just as an experiment and see how it looks. So 86 mouse curse.asm, okay, mouse curse, and oh, it inverts it. Oh, that's kind of cool. Check that out. So you can see the body of the hand just covers up the text. Well, you can't really tell it's covering it up because the hand and the text are the same color, but technically the hand is actually covering up the text because the screen mask here is set to 0, and that means that that part of the cursor is opaque. It covers up the background. But the parts of the screen mask that are set to 1 create a see-through cursor, and so the finger is now see-through, so it creates this really kind of cool effect like that. That is pretty cool. Anyway, okay, so that's it. That's interrupt 33.9. This is the basic way that you create a graphical mouse cursor in DOS. A big limitation of this is, again, the cursor can only be black and white. As far as I can tell, I don't know this for a fact, but I'm going to guess that this was used by Sierra in their early point-and-click adventure games, meaning King's Quest V, Space Quest 4, Leisure Suit Larry 5, Police Quest 3. I'm pretty sure that all of those games did this to set the mouse cursor, and the reason I say that is because all those games had a black and white mouse cursor. But if you played a lot of Sierra Adventures, you might remember that later Sierra Adventures tended to have color mouse cursors. King's Quest VI had color mouse cursors. Freddy Farkas had them. What else? I'm just trying to think. I don't know. I don't need to make a comprehensive list right now, but you get the idea. So how did they do that? Well, they did it by not doing this. So if you want a color mouse cursor, you're going to need to create your own routine to read mouse movement. This function that we created here is relatively simple because it's using a built-in routine. Interrupt 33.9 is a built-in routine that's built into the mouse driver, so you don't really need to do much. All you have to do is just define the look of the cursor here, and then just set your parameters. Just set the hotspots and provide a pointer to your cursor bitmap, and that's it. It does everything for you. It automatically makes sure that the cursor moves around in response to the mouse, and it makes sure that the cursor doesn't trash what it passes over. Like it restores the background after the cursor passes over it. If you want to make a color cursor, you'll have to do some of that work yourself. You'll have to not use interrupt 33.9, but rather you'll have to read the mouse input directly. I say directly, I mean, it doesn't have to be directly in the sense that you read directly from the hardware port, but you will need to use a function that provides you with the mouse location. And the interrupt for that is int33.3. So let's go ahead and make another program. Last time I called it red mouse because I used a red pixel. So let's go ahead and just call it red mouse. And once again, let's set the video mode. So we have AH0 tells the interrupt 10 to set video mode. We want mode 13H, which is 320 by 200, 256 color VGA, and call interrupt 10H. So the above 3 lines just set the video mode. Okay, fine. So the interrupt to get the mouse position is interrupt 33.3. So this is really all you have to do to get the position. After you do this, then what happens? Let me write as a comment below. Let me write what this actually does. Now CX is the horizontal or X position of the mouse from 0 to 639. DX is the vertical or Y position from 0 to 199. So, nice. So this is still fairly easy. We're still using a function here to tell us where the mouse is. That's easy enough to do. But now we have to position something. We have to put something on the screen ourselves. The other interrupt just basically automatically put your cursor wherever the mouse was. But here we have to draw something where the mouse is. So what we can do is, I'm just trying to think of the most sensible way to do this, just as an initial demo. Let's go ahead and hold on. Let's first set up the part that actually writes to the screen. So we're going to do a direct memory write. This is the part that failed with FreeDOS because FreeDOS doesn't let you do this, but DOSBox does. So I'm going to write directly into memory, and when you do that, you first want to set your data segment because we're going to write data into memory, and so we set DS, the data segment, to tell the processor what segment of memory we're writing the data to. So the VGA memory mapped video segment is A000. But again, because it starts with an A, it starts with a letter, you have to, A86 will require you to put a 0 at the beginning, pad it with 0 to indicate that that's a number. And I think it's implicit, I think that it will implicitly interpret this as a hexadecimal number because you can't have a decimal number with an A in it. Once again, it's not a digit in decimal numbers, but let's just to be safe, let's put an H on the end so that we really explicitly define this as a hexadecimal number. So that's our VGA, put a note there, VGA video memory segment. And let's put a color into AL. Let's put 40. 40 decimal is red. For some reason, I like to use decimal values for the colors when I'm doing stuff like this. You can also use hexadecimal numbers. It really doesn't matter. And the value here, I mean, this can be anything you want. This is just the color. The only difference here is the number specifies what color this pixel will be. So 40 gives you a nice red color. Later on, we might see different colors, but that's fine. We can just leave that at that for now. That's why I call this red mouse, because I used a red pixel for this. And now all we have to do is, well, we need a register that contains the memory location that we're writing to. I used BX for that, so I used a command like, come on. Is it not going to let me? Really? It's not going to it doesn't let me write square brackets. DOSBox does not let me write square brackets. Oh, DOSBox, why you do this to me? I have so many problems just editing a text file. How can it be this hard to edit a text file in DOS? It really shouldn't be this difficult. Okay, fine. So once again, I'll go ahead and edit the file outside of DOSBox. I'll edit in my operating system. What did I call it? redmouse.asm. And I will type in these square brackets with my keyboard here. Okay, that worked fine. So let's go ahead and say edit redmouse.asm. There we go. Now the square brackets are there. So what I did was I said move bx al. What this does is it moves the contents of al into the memory pointer provided by bx. So this works fine, but the problem is, of course, we have to, well, not a problem, but we have to set bx to something reasonable first. So let's see, how should we set bx? Let's start with the vertical position. So I'll go ahead and say, yeah, so dx contains the line that the mouse is on. Now, the problem here is that needs to be multiplied by 320 because, again, our video mode here is 320 pixels wide. So each new line of vertical positioning is another 320 bytes of video memory. So let's do this. I'll say, I'll use AX because you can do math with AX. I'll move 320 into AX and then just say multiply DX. That's fine. This what this does is it puts the number 320 into AX and then immediately multiplies that by DX and puts the results of this multiplication into AX. So AX is now DX times 320. So that's fine, and then let's move the results of that into bx, so that this will then move it will then move whatever bx contains, that will be the pointer in memory that we move to. So this will do something. I actually haven't tested this. I'm curious how it will look. It probably won't look that great, but it's a start. But the thing is, we need to keep doing this. So what I'll do down here, after this is done, I'll say I'll jump to something called main loop to keep doing this, and then we just need to define where main loop is. I'll put it up here, because this is where we actually check the mouse position, so obviously this makes a logical point to jump to. So main loop, yeah, it just keeps doing this then. Yeah, that should be fine. The only problem with this then is if we run this program as is, there will be no way to quit it because we've made no provision for the user to actually quit the program. So let's do this. At the bottom, I'll make another code point, whatever you want to call it, called quitter. And here I'll put the usual code to end a DOS program. Only question then is, how do we get there from here? What I'll do, before checking the mouse position, I'll check the keyboard. Let's check the keyboard input port and see if the user pressed Q to quit. That seems like a safe plan, I think. So I'll say NAL 60 hexadecimal. So 60 hexadecimal is the keyboard input port. This basically puts, if the user pressed a key, it puts the key that they pressed into the register AL. And then what we'll do is we'll compare AL with 10 hexadecimal. The reason being the Q key has a scan code of 10 hexadecimal. So if AL matches 10 hexadecimal, that means the user pressed the Q key. And then we say jump equal. If AL actually equals 10, then jump to the thing we called quitter, because that means that the user pressed Q to quit. I think this will work as is. At least it shouldn't I'm hoping it doesn't crash. That would be a good result. But I'm curious how it actually looks. Let's see. This isn't the full program yet, but let's give it a try and see how it looks. Okay, no error messages. Again, that's a good first sign. So how does it look here? Okay, yeah. So you can see it actually it actually works pretty well. It actually does the vertical perfectly. So you can see on the left side, I hope you can see on the left side, there is just a vertical line of red pixels. Hold on, let me quit. Let me press Q to quit. Let me make sure this works. Yes, it does. So if you press Q to quit, that works fine. I'll do CLS to clear the screen and run red mouse again. So take a look at the left side of the screen. There's a red pixel there, and if I move the mouse up, see, it's creating a line of pixels that goes up. And if I move the mouse down, yeah, it actually makes a line of pixels that go down. So that works perfectly. The vertical element is working fine. It just obviously has no horizontal element, so you only have you've got a line of pixels on the left side of the screen, which is kind of it's actually that went better than I expected. I was expecting something worse than that, but that works fine. So that's good. That's a good beginning. But obviously we need to add the horizontal component, and unfortunately that's not as easy. Let me go ahead and show you what we... Actually, you know what? Let me do this. Let's do this. We can make it really easy and just... So, CX contains the horizontal position of the mouse. So actually, what I can just do at... this point here, just before we load BX with AX, I'm going to say add CX to AX. So basically add the horizontal component to AX, stick it in BX, which contains the memory pointer, and then that's it. This will work, but it won't work quite as nicely as I'd like because, well, you'll see. Let's take a look at how it looks. So there we go. So you can see, I mean, you can't see exactly where I'm moving the mouse, but you can see obviously that it's doing something. So it is now moving in 2 dimensions. If I move the mouse to the left like that, it goes to the left. If I move the mouse down, it goes down like that. If I move the mouse to the right, it goes to the right. And if I move the mouse up, it goes up like that. There are 2 weird problems with this. First of all, you probably noticed that if I move the mouse horizontally, each pixel has a black pixel between it. So basically, it doesn't... If I move the mouse vertically, I have an unbroken red line, but horizontal movement gives me a broken red line. Why is that? Well, that's the first problem we have. The second problem we have is if I move the mouse off the right side of the screen, watch what happens. It wraps around and comes in again from the left. So this is the right edge of the screen now. And if I go back to the left, again like this, yeah, it wraps around and comes back from the right. So this program works perfectly except for that one minor detail. Otherwise, it looks pretty cool. But why is it doing that? Well, the reason why it's doing that, you can probably guess already, is because CX is actually double wide for the resolution that we're using. So once again, our resolution here is 320 pixels wide, but CX actually goes from 0 to 369. So it's twice as wide as it actually should be for this resolution. So the simplest thing to do, well, the logical thing to do, is to divide CX by 2. So how do you divide CX by 2? This is unfortunately not quite as easy as multiplying DX by 320. What you can do is, let's stick CX into AX, because again, you can do math with AX. And then what I'd really love to do, like what would really be the simplest thing, is if I could just say divide by 2. Unfortunately, you can say multiply, but actually, I don't know if can you do an immediate value for multiplication? I'm not sure that you can do. But in any case, the divide command can't take an immediate value like this. You have to divide by a register. So what you can do is load 2 into BX and then say divide by BX. this kind of works, but it has a problem. What you can also do, actually, what you can also do is just use BL. And then divide by BL. This works perfectly except for the problem that BL is an 8-bit register. And so the program then crashes when the user moves the mouse about 2/3 of the way across the screen. This works perfectly as long as the mouse is in the left side of the screen, but the problem is an 8-bit register like BL only goes up to 256. It will not go up to the 320 that we need because it's only 8 bits. So the program will work fine as long as you're doing this, but as soon as you move the cursor to around here, bam, it just crashes because BL can't handle the values that you're trying to put into it now. So we need to use a 16-bit register, and we can use BX for that. I mean, it's fine. BX is a 16-bit register. So this seems like it will work. But there's a problem. If we do this, if I ran this right now, it would probably crash, and it might even crash, it would probably crash DOSBox, actually. The reason for that is because of a quirk in the instruction divide by BX. Divide by BX divides the 32-bit value in actually in DXAX by the by the 16-bit value in BX. So and stores the result in AX. So the problem here is we don't know what's in DX. And if you do this now, if you just recklessly say divide by BX, what's going to happen is it's going to try to store the results in AX, but AX is only a 16-bit register. And we're dividing by 2. That means unless DX is 1 or 0, the results of this division will probably be too big for AX, and we'll have a divide overflow, and things are going to crash with a divide overflow error. So to avoid that happening, I mean, we don't really need to divide by DX. The problem is just that the instruction we're using here, divide by BX, this instruction has to divide DXAX by BX. That's just how the instruction works. So what we can do, a simple way to fix this would be to say load DX with 0. Now this will prevent the program from crashing, but then we have the problem that DX still contains our vertical mouse position. So if we load DX with 0, we're overwriting we lose the vertical mouse position. So how do we deal with that? Well, in assembly language, when you have a register that contains the value that you want to preserve, you just want to temporarily change the register, but you want to restore the old value of it after that, you push and you pop. So we push DX onto the stack to save the vertical mouse position onto the stack. And now we can say move DX 0 and then divide BX, and then at the end we just say pop DX to restore vertical mouse position into DX. There we go. That's simple. And at the end here, let's so AX now contains CX divided by 2. So AX contains CX divided by 2. Let's move AX back into CX. So the whole point of all this, the whole point of this entire block of code here is just to divide CX by 2. That's really all that it does. I know it shouldn't be this complicated, but it is. So again, we move CX into AX because you can do math with AX. You can't just do divide by 2. You have to divide by a register, so we stick 2 into some register. Here I put it into BX. And then, because divide BX actually divides DXAX by BX, we have to actually save DX, make dx 0, do the division, and then restore dx. And then at the end, we put everything back into cx because cx is where we originally got the number. So cx just now is what it used to be divided by 2. So, that's it. That should work. Because the only problem we had last time we ran this program was that the horizontal position, or the horizontal result of checking the mouse position was double wide. It was twice as wide as we needed to be. So just dividing by cx should actually fix that problem, because we had cx here. So now we have the correct value in cx that we're adding to ax. So this really should work. That it should be that simple in theory. So let's go ahead and run red mouse and see how it works. Let me get my mouse in DOSBox. And would you look at that? It works perfectly. So now when I move the mouse horizontally, I get an unbroken line, and it stops at the boundaries of the screen. So I can go up here, I can go down here. Yeah, it correctly stops at the boundaries of the screen. It doesn't wrap around in that weird way that it wrapped around before. And wherever I move the mouse, the pixel follows. Now you might ask, how do you erase the old pixels? Because obviously to have a proper mouse cursor, you can't just have the cursor leaving trails like this. You need to restore what was in the background when the cursor moves away. Well, that's the very definition of a sprite. So a sprite is basically a two-dimensional shape that slides around on the screen. So you can move it somewhere, it covers the background for the moment that it's there, and then when it moves away, the background gets restored to what it was before the sprite came over it. I'm not going to talk about how to make sprites in this video because that's graphics work. There are a lot of videos explaining how to do sprites, sprite graphics in DOS. So if you're curious about how to do that, you should be able to find the information somewhere else. And in any case, this video is already long enough just talking about mouse stuff. This video is about how to do mouse routines in DOS. And so, yeah, how to actually make the graphics look proper so that the cursor doesn't just like wipe out everything on the screen. That's graphics stuff. So I might make a video about that in the future. But for right now, this mouse program is running perfectly. This is how you would make a color mouse cursor. Again, here I'm just using 1 pixel because obviously 1 pixel is easier to do than a whole cursor. But you do the same thing here. You would create, you would put on the screen not 1 pixel, but a whole cursor's worth of pixels, and then slide that cursor around as a sprite on the screen, and obviously erase old cursors from the screen so you don't end up with a trail of cursors on the screen like we have here. But that's it. This is how you would do a color mouse cursor in DOS. So there you go. Very nice. So I'm happy that that worked out well. And now for the finale. The finale is actually not that impressive. I think this program that we just saw is the most visually impressive. But just to round things off, I want to make a program that lets you click on things. So this program will actually be the most complicated one of all. Not because it does anything really fancy, but just because there's a lot of checking that you have to do when you're clicking on things, because you need to make sure that you're clicking on, you need to verify where the mouse is clicking. So let me go ahead and actually, let me quickly pull up a program that I wrote a while ago. Where is it? Yeah, here we go. Okay. So this is going to take a while to go through, and this video has already been pretty long, so I'm going to go ahead and try to just breeze through it. I'm not going to explain as much. I'm just going to go ahead and start putting stuff together and try to quickly explain it on the fly as I go. So what I wanted to do here, let's call the last program 3 colors, because I'm going to have 3 color options on the screen. So again, let's go ahead and set our video mode, move H0 and move AL13H in 10. Okay. Now in mode 13H. I'll say video mode 13H. Okay, fine. So again, we want to set our, actually, you know what? Hold on, scratch that. Delete 3 colors, and I'll copy mouse cursor.asm into 3 colors, because this gives us our cursor already. With this, we already have apparently A86 stripped the 3 from the beginning and gave me a program called colors because it didn't want to create a program called 3 colors. Well, that's interesting. Okay. Didn't realize it does that, but okay, that's fine. So here we go. So we have our cursor. That's a good start. So we don't have to go, reinvent the wheel. We have the cursor already on the screen. Now what we want to do is, let's go back into 3 colors and, right. Right, so here is where, right, so this turns on the mouse cursor. Okay, so let's do this. Let's go ahead and print 4 words on the screen. So to do that, you use interrupt 10 2. And we need to set a few things here. Let's make BH 0. BH should be 0 for graphics modes, and we are doing this in graphics mode. DH is the row. So I'll go ahead and start on row 4, and then DL is the column. So I'll use column 5. And right, so that will actually set the cursor position. And then, right, so what's next? Right. So there might be a better way to do this. I did this using interrupt 10E, I think. Yeah, interrupt 10E. So if you move AHE, this is the function to write text in teletype mode for interrupt 10. Again, we need a few right, okay. Need a few parameters here. So BH can just be 0. That's the page number, but it's for text modes. So we don't really care here because we're not using a text mode. BL is the color for graphics modes. I'll go ahead and use color C. Text color. 4 is red, but C is bright red. So let's use bright red. Let's use a nice bright red color. And what we need to do is, right, AL needs to be the character to write. So what I'll do is, yeah, okay. So down here, actually, let's go ahead and create some strings. I'll say, I'll create a red string. Let's call it red string, and let's just say data byte values red. And while I'm here, I might as well do it for the other color. So I'll do red, green, and blue. So I'll do a green string called green, blue string called blue, and then we also want a quit option. Don't forget to give the user the option to quit your program. So I'll say quit string is a data byte containing the text quit. Okay, we'll come back to those later, but right now we're doing just red. So we have what do we have? We have... Right. So I wanted to... Right. So I used the LODSB assembler command to loads character to write into AL. So that's fine. We can get rid of that because AL will now contain the character to write. But what we also need to do is set DS to be the current CS. Why? Because that's just how the LODSB command works. And then CX will be how many times we go through this loop, because red contains 3 characters. And then SI needs to be the offset of red string. Okay. And then down here, we need to decrement CX, because CX contains how many times we do this. Check if CX is 0, and if it is not, jump if not equal. If it is not 0, then we need to run LODSB again. So let's create a label here, call it red text, and then we can say jump if not equal red text. Okay. This should work as it is to print red. So let's go ahead and test this out. A86.3. Again, I know I'm not explaining this very well. This is going to take a while, and I want to kind of breeze through it. I don't want the video to drag on at this point too much. So let's just, yeah, works fine. Great. Okay, so let's go back and continue this. So we can actually... So all of this is for printing the text red. We can actually copy and paste that for green. So this part prints green, and just so we don't get lost, I'll say this part prints red. Okay, so now this part prints green. So everything here is the same except for the row. I'll use the same column. So let's go 4 rows down and make this row 8. What needs to change here? Obviously the word green contains 5 characters, so we change that. Obviously we want to take our green string, and this will be called green text. And I think the only other thing that we need to change is the color. Let's see, what did I use for green? Green is A. Right. 2 is green. A is bright green. And then all of this can be the same. And then also we want to change this here. That should be okay. Copy and paste it once more. I'll once again move 4 rows down. That puts us on row C. We're doing blue now, which contains 4 characters. And obviously we'll want to use the blue string. We'll call this blue text. And what color did I use for blue? 9. Okay. Which is the same in decimal and hexadecimal. So text color, 1 is blue actually, and 9 is no in German. It's also bright blue. And then we want to change this so that it says blue text, and one last time. So now we'll print the word quit. I put quit on row 10 hexadecimal. 4 because quit contains 4 characters. And we had a quit string, didn't we? I think we did. So let's make a label called quit text. What color do we want to use for this? Let's just use regular DOS white text, which is 7. 7. 7 is white, and I think DOS has also this weird bright white thing, which is F, right? F is bright white. So there we go. And then quit text. All right, so theoretically, if I did everything correctly here, now we should have a program that prints these words on the screen and then quits. Yes, it works perfectly. So now we have a program that does all of that. Cool. Okay. So what we want to do now is right. Okay. Let's get back into the editor here and do this. I'll just make a note here that this is to actually exit the program. So I'll make a mouse loop here because what we want to do is keep checking the mouse position. Now, we use interrupt 33.5. 5 is the function to get mouse button press info. We actually don't need any, that doesn't need any input parameters. AX now contains the results of what mouse buttons are pressed. So what we want to do is compare AX with 1. Because 1 means the left mouse button is pressed. So if the user is pressing the left mouse button, then let's move on and run the code down here. If not equal, if the user didn't press the mouse button, then just jump. So jump if not equal back to mouse loop. Okay, now we need to use the familiar int 33.3. This gets the mouse position. And once again, this means CX is the horizontal X position from 0 to 639. And DX is the vertical Y position from 0 to 199. Okay. Now the trick is this. Let me show you what I did. I'm looking at the program that I wrote before, and I did basically this. First, I compared CX with 80. Now, CX is the horizontal position, and the location of the text on the screen is it's 40 pixels. So the left side of the let me show you what I'm actually, no, I can't run this program now because it'll get into an infinite. There's no way to quit the program right now, so I can't actually run this as is. The left side of the words on the screen are 40 pixels from the left side of the screen. That means we need to check CX for 80 because, remember, CX is double wide. So 40 pixels actually means a value of 80 in CX. So we check if CX is 80, and then jump if less. If CX is less than 80, jump back to mouse loop. If CX is left, then the left edge of the text, go back. So this means basically that nothing happens if the user clicks to the left of the text. Now, let's do a vertical thing. Let's compare DX with, I just found this out by trial and error. There's probably a better way to do that, but I just did this by just manually just checking, tweaking these values until they worked. 32 is the top of the text that says red. So if our location is less than that, again, go back, because the word red is at the top, and so if the mouse is above the word red, then obviously the user didn't click on any, text. So now let's compare, whoops, what happened? Oh dear. I must have put in a wrong keystroke. Sorry. Okay, compare DX39, which is the bottom of the text that says red. So at this point we say, okay, DX is not less than the top of red, meaning it's below the top of red, but it is less than the bottom of red, which means it's on the red text. So if this is the case, then let's go ahead and jump to draw red pixel. We don't have this routine to draw a red pixel yet, but we'll put it in later. And then for, let's see, next one was, right, 64. Compare DX with 64, top of green. If it's less than that, then go to mouse loop, because this means it's more than the bottom of red, but less than the top of the green. So basically the user clicked between red and green, so they didn't click on a word. So go back to the mouse loop, compare DX71, which is the bottom of green, and then we'll say if it's less than that, then do draw green pixel. We'll draw a green pixel to show that we registered the mouse click on the word green. Moving on, the next one that I had was 96, which is the top of blue. And if it's less than that, then go to go back, because that means that the person clicked between green and blue. But if DX is more than 96 but less than 103, which is the bottom of blue, that means that they clicked on blue. So draw blue pixel. Then top of quit means the user clicked between blue and quit, so jump back to mouse loop. But if DX is less than 141, wait, no, duh. Oh, right. How did I do this? Okay, I see. I think... Right, okay, so here's what I did. So, yeah, okay, I see. Sorry, I got confused. So here I said compare DX with 134, which is the bottom of quit. And then I said jump if greater than. Hold on. This editor is giving me some problems. Actually, I'm finding out that I don't like the editor program that comes with FreeDOS. Jump mouse loop. So yeah, so if the vertical value is greater than the bottom of quit, then go back to mouse loop. So I'm hoping that the program should work as is, except for the problem that I don't have. Problem here is I don't have routines for the pixels, so I think it's going to complain. Yeah, it's going to complain and say draw blue pixel, draw red pixel, draw green pixel don't exist. So actually, before I run this, let's make sure that those routines do exist. What I could actually do is just stack them all up here for now, because clicking on them will cause the program to quit. Now, as the final purpose of the program is not just to quit, but I just want to make sure at this point that I haven't made a huge boo-boo, that I haven't made some silly mistake that's messed everything up. So it looks okay. So the text is here, and if I click here, if I click between the words, nothing happens. But if I click on the words, there we go. it quits. So that's basically it. You've already seen how to make a program that recognizes mouse click input and do the positioning. And I mean, if you wanted to do it better, you could say, I mean, the problem that we have now is I'm not checking for a right boundary, so I can click way over here, and as long as the vertical is correct, then it still quits the program. Also, see how it corrupted the word red there? The reason for that is because I'm turning on the mouse cursor and then putting the text on the screen. So actually, let's rip out the part where we turn on the mouse cursor and put it down here. That should work better. So now if I say do colors and then quit and run the program again. Yeah, see, so even though the mouse was over the text, it doesn't corrupt the text now. So I would print the text on the screen first and then turn on the mouse cursor. That will prevent that problem with the cursor corrupting the text underneath it. Okay, that's fine. And clicking on quit also causes it to quit. So that's fine. That's basically most of the program there. And then if you really want to make these functions actually do something, I mean, we don't have to actually because this is not a graphics demo, it's a mouse demo. But let's go ahead and quickly just plot a pixel here. So I'll say move ds 0a000 hexadecimal. Actually, the H is redundant because it's implicit that it's a hexadecimal number since it has an A in it. And I'll say load AX with 40. 40 decimal is red. And then we'll say move BX. Yeah, I used 28,000. This is the memory location, so this is basically where the pixel shows up on the screen. You can put any number in here, it just changes where the pixel is. 28,000 puts it kinda in the middle of the screen. It's not exact, but it doesn't have to be exact. And then we just say move. Oh, and I can't do square brackets here in this editor, so I will need to. Oh, I don't have square brackets anywhere here in this program, do I? No, I do not. So I will have to once again quit this for a second and edit the program outside of DOSBox. Sorry, give me just a second. Where are we? There we are. So I'll put in the square brackets there, quit out of that, and okay, we're back. So I was here, right. So move BX AX. That's it. This will actually put the red pixel on the screen. And then, of course, we want to jump back to mouse loop. And I will copy and paste this for the other 3 pixel drawing routines because they're all the same except for the color. The only thing that's different is here I will load, for green I'll load 49 because 49 decimal is a nice green color. And blue, what did I use for blue? What color did I use for blue? 33. So 33 decimal is blue. Okay, great. And that's actually it. The only thing that we need is to be able to quit. So I'll put a routine here called quitter. And then how are we going to activate quitter? I'll actually say, let's do this. I'll actually say, since this is the bottom of quit, I'll say if it's less than the bottom of quit, then jump to quitter, since that means that the user clicked on quit. I think that's it. I think that is our program. So let's test it out now. So if I click here on red, I get a red pixel. Very nice. Green, get a green pixel. Blue, get a blue pixel. Click on quit. It quits. Great. Okay. That's it. That's our program. Oh, it even still has... The cursor's even still see-through because I left the screen mask in that makes the finger part see-through. So that's actually kind of cool. Cool to look at. So yeah, that's it. Blue pixel, red, green, red, green, blue, green, red, blue, come on, blue, green, red, blue, quit. All right, there you go. So that's how you click on things. Very sloppily done. I admit, I mean, this is really just very sloppy code. Whoops, I need to, there we go. This editor doesn't even show up correctly if you're in a graphical video mode. But anyway, so this is the program that does that. And you could make it a lot better. I was originally planning to draw a whole rectangle, not just one pixel, but a whole rectangle. And I went looking for routines to draw rectangles in assembly language. It turns out drawing a rectangle properly in assembly language is like 4 pages of code just to draw the rectangle alone. So I thought, well, you know, it's not really worth it because, again, this is not a graphical video. It's not about how to draw graphics. This is about how to do mouse stuff. So now you've seen how to make a mouse cursor, how to check the mouse position and move the mouse around based on, or move the mouse cursor around based on mouse movement, and you've seen how to recognize mouse clicks and check where the user clicked on the screen. That's it. 3 programs demonstrating how to do mouse stuff in DOS. I hope this was informative. I hope it was interesting. I apologize as usual that it was a little bit disorganized and kind of here and there, and you know, it probably could have run a little bit smoother, but I'm pleased with how things went overall. I think in the end things went pretty much as I hoped that they would. So yeah, thanks for watching, everyone. This has been how to program mouse routines in assembly language for DOS. I will talk to you folks later. Bye-bye.